Let's examine the stateless autoconfiguration method for IPv6 address deployment. First of all, stateless autoconfiguration does not use a DHCP server at all. However, it still allows our end stations or our devices to automatically generate an IPv6 address, a global IPv6 address. That's right, automatically generating it. Might seem strange at first, but once you see the process here, you'll realize that it works quite well. So here's how it works. Our devices, when enabled for stateless auto configuration, and by default, Windows 7 and Windows 8 devices are automatically enabled for stateless auto configuration. They will send out a router solicitation message. And a router solicitation message is sent so they can find a router on the network that can advertise to them a prefix that can be utilized to automatically generate an IPv6 address. So that's the first thing they're looking for. They're looking for that link prefix from a router advertisement. So if here's my router, here's my layer 2 switch, here's some devices in the network. Let's connect everybody up. They're all part of the same local area network. This interface right here is going to be enabled for IPv6. It's going to have a global unicast IPv6 address assigned to it. So for example, 2001 colon DB8 double colon 1/64. And when IPv6 unicast routing is enabled, this interface will send out those router advertisements that are needed by those end stations to determine the link prefix. So the link prefix is the first 64 bits of that IPv6 address. So in this case, the router advertisement is going out, and these end stations are going to receive that router advertisement, and they're going to realize that 2001 colon DB8 colon 0 colon 0 double colon /64 is their subnet prefix, the first 64 bits of their IPv6 address. And then from there, they utilize the IEEE EUI 64 standard for determining what the lower 64 bits are going to be, which is the interface ID, or the host portion of the address. So how is it accomplished? Well, the IEEE EUI 64 standard says take the 48-bit MAC address because it's unique within the local area network already, and use that for the interface ID. But wait a second, it's only 48 bits long. We need a 64-bit address. So here's what happens. The address is broken in half. There's the first 24 bits, there's the last 24 bits. And in between, FFFE is added. FFFE is added. How can you remember that? Well, a student once said to us in a class, fill the field with fluff every time. If that's how you want to remember it, go right ahead. Fill the field with fluff every time. So, is that all that happens? No. It goes a step further. And the seventh bit from the left gets flipped. So if the seventh bit from the left is a 0, make it a 1. If it's a 1, make it a 0. Let's examine this in a little more detail just to make sure we are fully clear about what is going on. So let's go to PC1 in our environment, and let's issue the ipconfig switch all command so we can identify the MAC address. And the MAC address of PC1 is right here, 0800275D06D6. Let's write that out. So we have 08, 00, 27, 5D, 06, D6. Break it in half. Where's the halfway point? 1, 2, 3, 4, 5, 6. Halfway point's right there. Right there. So what we'll do is we'll put 08, 00, 27, F, 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 E, 5D, 5D, 06, D6. However, as we said, we're not done. The 7th bit from the left has to be flipped. So what is the 7th bit from the left? Well, if we examine this hexadecimal value, it's 0. And each hexadecimal value is made up of 4 bits. So what is 0 in binary? It's going to be 0000, because it's 4 binary bits for every hexadecimal value. And if we go to 8, what do we have? We're going to have 1, 0, 0, 0 represents 8. So where is the 7th bit from the left now? Well, if we do the math, or just count, I should say, not do the math, but count. 1, 2, 3, 4, 5, 6, 7. There's a 7th bit from the left. So we got to convert that. We convert that to 0, 0, 0, 0, 1, 0, 1, 0. And then if we convert these back again, you have a hex value of 0 and a hex value of what? A. Because 10 in binary equals A. So our new interface ID is going to be 0A, 0027, F, 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 E, 5D, 06, D6. So we're going to have 0A at the beginning and FFFE put right in the middle. If we go back to our PC, PC1, and we look at the link local address, which utilizes EUI 64, we can see that 0A, 00, 27, FFFE, 5D, 06, D6. That's the number we figured out. It's just been truncated. That's all. The leading zeros have been dropped from each field. So 0A, 00, 27. Let's examine that again. 0A, 00, 27, FFFE, 5D, 06, D6. It's accurate. 5D, 06, D6. Perfect. It lines up exactly. So that is how our Windows 7, Windows 8 devices are going to automatically generate the interface portion and the subnet prefix, so their IPv6 global unicast address, using stateless auto configuration.